Now let us see the students of 11th standard. So last time we have discussed about the torque acting on a particle, then angular momentum of a particle, and then torque and angular momentum of system of particles. And in that topic we have seen that the Newton's third law of motion for rotational motion, and it was d vector capital L by dt equal to t external. That means the time rate of change of total angular momentum of a rigid body is equal to the resultant external torque acting on a body. So this is said to be Newton's third law for rotational motion. Now on the basis of these topics we have to discuss about the equilibrium of a rigid body. So what is equilibrium of a rigid body? That is mechanical equilibrium of a rigid body. Under which condition can you say the body is in mechanical equilibrium? So actually we have to see the effect of external forces on a rigid body. What effect of the external forces have on rigid body? So we have studied the two equations. One is Newton's second law of motion for linear motion, and next is the Newton's second law for rotational motion. What these two equations says? So Fe external equal to dp by dt. This equation says that the external forces or the resultant external force, because what is the meaning of this statement? The time rate of change of total linear momentum of a body is equal to resultant external force. That means the external forces which are acting on a body or the resultant external forces which are acting on a body can change the translational state of motion of a body. Translation state means linear state of motion of a body. That means they can change the total linear momentum of the body. On the other side, the Newton's second law for rotational motion, time rate of change of total angular momentum is equal to net external torque. So this equation says that the external torques, that is the total torque acting on a body. So here we have to consider the forces acting on the body are the external forces. There is no importance of the internal forces. So these external torques are arising due to external forces. So simply external forces we have to consider as a forces. So this equation says that the external torques or the total torque acting on a body can change the rotational state of motion. Rotational state of motion of a body, that means it can produce the total change in angular momentum. So this equation says that they changes the total angular momentum of a body. Now there are two conditions for a rigid body to be in mechanical equilibrium. A rigid body is said to be in mechanical equilibrium if both of its, number one, the linear momentum of a body does not change with time, and another is angular momentum do not changing with time. That means if there is linear momentum not be changing, dp by dt external force equal to 0. So force is 0, that means there is no linear acceleration, and torque is 0, that means there is no angular acceleration. So here linear momentum do not changing with time as well as angular momentum do not changing with time. It means what? The body neither has linear acceleration nor angular acceleration. It means that if the total force acting on a body is 0, the total force or resultant force acting on the rigid body is 0. That means the vector sum of the different forces acting on the body is 0. That means the sigma of Fi equal to 0 and force is 0. Then it is said to be what? In translational equilibrium. Then the body is said to be in translational equilibrium. So this is the one essential condition. a body in translation equilibrium should have the resultant force acting on it is 0. And as the total force is 0, that means the total linear momentum remains constant, it does not change with time. And second condition is, if the total torque acting on the rigid body is 0, that means the resultant external torque acting on the body is 0. That means the vector sum of the different torques acting on the rigid body is 0. And when torque is 0, then according to this equation, dl by dt is 0. That means L remains constant, that means angular momentum does not change with time. That the body is said to be in rotational equilibrium means the total angular momentum of the body remains constant or it do not change with time. So we remember these two equations. One is sigma Fi 0, then the body is said to be in translation equilibrium. That means resultant force acting on body is 0, then it is in translation equilibrium. If resultant external torque acting on the body is 0, then it is said to be in rotational equilibrium. And if both are there, then the body is said to be in translation equilibrium as well as in rotational equilibrium. And this kind of the both equilibrium is said to be mechanical equilibrium. And these equations 1 and 2 gives the conditions of mechanical equilibrium of a rigid body. Now, for rotational equilibrium, that means there should be a resultant external torque acting on the body 0. We know in order to have the torque, there is a cross product of vector r and f, where vector r is position vector with respect to some reference point. So we remember here, if the reference point is going to be changing, reference point is going to be shifting, then also the rotational equilibrium condition is not be changing. The rotational equilibrium condition is independent of the location of the origin about which we are considering the torques acting on a body. So if the origin, that means the reference point, is going to be shifted, then also the translational equilibrium condition holds for a rigid body, and that you will see, you can see its proof in the example number 7.5. Let us see the further one. So earlier we have seen that there are the two condition of, there are two equations showing the conditions of translation equilibrium and rotational equilibrium. Now we will reduce these equations of translation equilibrium and rotational equilibrium from the earlier two equations. Which were the earlier two equations? The equation 1 and equation 2. So what was equation 1? The resultant external force acting on a rigid body 0. What was the equation 2? The resultant external torque acting on the rigid body 0. So this resultant external force can be written as the sum of the three components, one in x direction, another in y direction, and third in z direction. So when resultant external force acting on the rigid body is 0, then you can take individually the each component of resultant external force, x component, y component, and z component equal to 0, as well as resultant external torque acting on rigid body is 0. Then again this resultant external torque can be written as the sum of the three components, x component, y component, and z component. So again you can take each component of torque individually as 0. So equation 1 gives another three equations, and equation 2 gives another three equations. So thus we will get totally there are 6 equations. The equations 1 and equations 2 are equivalent to three scalar equations. Sigma of Fi from I equal to 1 to 0 gives sigma Fi x is 0, sigma Fi y is 0, sigma Fi z is 0, where Fi x, Fi y, and Fi z are x and y and z components of resultant external force Fi. Similarly, the resultant external torque acting on rigid body 0 from I equal to 1 to n implies sigma Ti x is 0, sigma Ti y is 0, sigma Ti z is 0. So where Ti x, Ti y, and Ti z are x, y, and z components of resultant external torque or total torque Ti. So thus, if there are 6 independent conditions 3 regarding resultant external force and 3 regarding resultant external torque. So thus we are having the 6 independent conditions. So thus if 6 independent conditions are to be satisfied, then and only then you can say that the rigid body is said to be in translation equilibrium and rotational equilibrium. That means it is said to be in mechanical equilibrium. But actually what happens? Whenever the forces are acting on the body, rigid body, then these forces are always be coplanar. And as they are coplanar, it means what? These forces either in xy plane or in yz plane or in xz plane. So here, but actually all the forces acting on the rigid body are coplanar. So we need only 3 conditions to be satisfied out of 6 for mechanical equilibrium of a rigid body. So out of 6, we now need only 3 conditions, out of which 2 conditions regarding forces which are coplanar and 1 condition regarding torque which is perpendicular to the plane in which the forces are there. So out of the 6 conditions we reduce to the 3 conditions. कौन सी 3 conditions for a rigid body in order to be having mechanical equilibrium? Out तो ये देखिए 3 conditions में से 2 कौन सी? तो 2 of these conditions corresponds to the translation equilibrium. 2 of these conditions corresponding to the translation equilibrium. And for translation equilibrium क्या होना चाहिए? Resultant force 0. लेकिन resultant force में से कौन से 3 component of force है? इसमें से कोई 2 component of forces mutually perpendicular 0 होने चाहिए. That is sigma Fix and sigma Fy equal to 0, or sigma Fy equal to 0 and sigma Fiz equal to 0, or sigma Fiz equal to 0 and sigma Fix equal to 0. So you can understand from this one, वो 2 ही mutually perpendicular forces which are lying in one plane should be 0. XY plane में है तो resultant force के resultant force का x component and resultant force का y component 0 होना चाहिए. अगर ये forces YZ plane में है तो resultant force का y component and resultant force का z component 0 होना चाहिए. अगर ये forces XZ plane में है तो resultant force का z component and resultant force का x component 0 होना चाहिए. तो in this way 2 of these conditions corresponding to the translation equilibrium, that is either sigma Fix equal to 0 and sigma Fy equal to 0, or sigma Fy equal to 0 and sigma Fiz equal to 0, or sigma Fiz equal to 0 and sigma Fix equal to 0. And what is the third conditions? So means that the sum of the components of the forces along any 2 mutually perpendicular axes in the plane must be 0, as I have said earlier. Sum of the components of the forces कौन सी direction में? तो sum of the component forces along any 2 mutually perpendicular directions में in a plane must be 0. XY plane में है तो Fix equal to 0 and Fy equal to 0, यानी कि x direction में लगने वाले सभी forces का x component की forces 0, y direction में लगने वाले forces का सभी का y component का sum 0 होना चाहिए. बराबर, this should be line. And third conditions corresponding to the rotational equilibrium is that the sum of the components of the torques, लेकिन कौन सा torques? Along any axis, and ये axis कैसी? Which is perpendicular to the plane of the forces must be 0. तो अब इसी टाइम पे जो भी torques लग रहे हैं वो कैसे है? अगर वो forces xy plane के है तो z direction में लगने वाले torque के sum of the components, sum of the torques should be equal to 0. That means the third conditions corresponding to rotational equilibrium is that the sum of the components of the torques along any axis, लेकिन वो axis कैसी? Which is perpendicular to the plane of the forces must be 0. So in short you can write out of 6 conditions, अगर ये 3 conditions fulfill होती है, then you can say rigid body is in equilibrium condition. कौन सी 3 condition? Due to forces sigma Fix equal to 0 and sigma Fy equal to 0. And at that time sigma Tiz, यानी कि torque is in z direction में लगने वाले should be equal to 0. Accordingly you can write the other 3 conditions. If you are accepting sigma Fy equal to 0 and sigma Fiz equal to 0, तो y component and z component के forces, तो फिर x component वाला torque का sum Tix should be equal to 0. Now, conditions of rotational equilibrium cannot be applied to a particle. कोई एक अकेला पार्टिकल अगर रोटेशनल मोशन करता है तो वो इक्विलिब्रियम रोटेशनल इक्विलिब्रियम में नहीं हो सकता. That's why the conditions of rotational equilibrium cannot be applied to a single particle which can performing rotational motion. And इसके लिए तो सिर्फ कौन से conditions, सिर्फ translation equilibrium की conditions apply कर सकते हैं. And conditions of translation equilibrium can be applied to a particle for its mechanical equilibrium. So if a single particle is performing rotational motion, then in order to have its mechanical equilibrium, only the conditions of translational equilibrium can be applied. Translational equilibrium मतलब resultant force acting on all this resultant force acting on a particle should be equal to 0. That means you can write sigma Fix equal to 0, sigma Fy equal to 0, sigma Fiz equal to 0. But there is no conditions for rotational equilibrium. Thus, for a mechanical equilibrium of a particle, only the vector sum of the forces acting on it must be 0. यानी कि ये पार्टिकल के ऊपर लगते हुए जितने भी फोर्सेस है वो सभी का रिजल्टेंट फोर्स 0 होना चाहिए. एज फॉर एग्जांपल कि एक ही पार्टिकल है, इसके ऊपर 3 फोर्सेस लगते हैं, 1 फोर्स इन राइट साइड डायरेक्शन, नेक्स्ट फोर्स इन स्लैंटिंग डायरेक्शन. तो इन दोनों का रिजल्टेंट फोर्स कहाँ मिलेगा? अकॉर्डिंग टू पाइथागोरस, अकॉर्डिंग टू लॉ ऑफ पैरेललोग्राम, ये बीच की डायरेक्शन में. तो थर्ड फोर्स कैसा होना चाहिए? एग्जैक्टली इन द ऑपोजिट डायरेक्शन ऑफ F1 plus F2. Then and only then in this situation vector F1 plus vector F2 plus vector F3 will be equal to 0. And you can see that these three forces acting on a particle are passing through one common point, and such forces are said to be what? Concurrent forces, as you studied earlier. That is, these forces must be concurrent forces. So sigma Fi equal to F1 plus F2 plus F3 equal to 0. After this we will discuss about the partial equilibrium of a rigid body.